Okay, let's do number 1. So this is 8.6. Number 1. Okay, so it says each pair of objects is similar, so you know that the shapes are the same, the sizes are different. So number 1 says here, Roman numeral 1 says, by what factor is the surface area of the larger object greater than the surface area of the smaller object? Now, you don't actually have to find the surface area of each to figure this out, right? What's the key between the areas? What's the key between the areas? Just answer the questions that I asked. Don't be talking while I'm talking. What's the connection? Okay, does it have to do with the scale factor? So area 1 times something to do with the scale factor equals area 2, right? And what is that? It's K, is it just K? K, sorry, K squared, right? Okay, so by what factor is the surface area of the larger object greater than? Okay, so all we need to do is we need to find K and then square it, right? So you don't have to find the surface area. So what is the K value, the larger one? So it's 3. So K is 3 divided by 1.5, which is 2. So K squared is 2 squared. K squared is 4. So does that make sense that the surface area would be 4 times as big if the K is 2 times as big? Question about that? Number 2 says, what factor is the volume larger? Well, again, we don't have to find the volume. We could, but that would be the long way. We could go from the K value, right? So volume 1 times K what? No, cubed is volume 2. Okay, so we're close. We know that the K is 2. So K cubed is 2 cubed. K cubed is 8. So the volumes are 8 times. The volume for this one is 8 times as big. Okay? So by what factor? For the areas, it's 4. For the volumes, it's 8 for number 1. Okay, take a minute and do B. Just right now. Just make sure you're on the same page, that you can get the right answers for B. Okay, so go ahead and do B right now. The exact same way. Okay, so you should have, because the K is 3 over 2 or 1.5, then the areas are related by 1.5 squared, which is 2.25. And the volumes are related by 1.5 cubed, which is 3.375. Any questions about that one? Yep. Yeah, this question is saying how much bigger is the larger object. So you always kind of start with the larger object on top. Yeah. Because you want to have a number greater than 1 because the object is larger. So, yeah. If you're not sure, then it's always the kind of the model or the representation on top, the one you're going to on top, the values, and then the values, the original one, the ones you're coming from, is on the bottom. Yeah. Okay. Okay. So the rest of your assignments. 8.6, so it's 1 to 7, choose one from 11 to 20. And if you need to look up some videos for chapter 8, you can on the website there, mrmathwell.com. I believe I have a video for number 7. You need to look at it. Let's see. Yeah. Oh, number 11. Oh, I don't have a video for number 7 up there yet. So maybe I'll do number 7 with you once you get a chance to do that, or maybe I'll do it now. Yeah, so number 7 says the dimensions of a right octagonal pyramid. So that's this. It's got an octagon or 8 sides on the bottom. It's a right pyramid. That means that the line from the tip to the middle of the base forms a 90-degree angle with the diameter. So this line here and this line here would form a 90 degree. That's what a right pyramid is. It says it's enlarged by a scale factor of 1.5. So it doesn't matter what the numbers are. The simplest would be 1 to 1.5. Or you could do like 2 to 3 or whatever. But the question says determine the value of each of the following ratios. So the volume of the large pyramid to the volume of the small. Okay. Remember, that's just k cubed, remember? So if k is 1.5, then the ratio here would be k cubed, right? Which is very similar to the question that we just did. Wasn't it? Yeah. So k cubed is, was it 3.375? So it looks like that would be your ratio for A. Does that look right? Okay, what about the surface area of the large pyramid to the small one? Surface area now? Well, that's going to be k squared, right? So k is 1.5, so this would be 2.25. That makes sense? Because we're talking about area now. See the perimeter of the small pyramid. Now, perimeter is just a length. It's just a dimension. Even if it's got a bunch of lengths added up together, it's not an area or a volume, so that's the same as a length. So the perimeter is, for C, the ratio is just K, or 1.5. All right, easy. Should be good. Oops, what's going on there? Okay, let me just double check some things on that, make sure we got that right. What is going on? Hello? I'll figure it out.